Here we are going to talk about the supporting technologies in the mobile GIS. So the supporting technologies includes three parts. The first technology is the mobile devices, like we mentioned earlier. So the reason that we have these, you can say the mobile GIS technology trend is due to the advance in the mobile device. So of course, the main reason is because of the smartphone. But however, beside the smartphones, actually, if you talk about the mobile GIS in general, then smartphones they are just a way to support the mobile GIS. There could be different ways to support mobile GIS as well. So, for example, the navigation devices that can be used on the cars, that could be called as one of the mobile device that people can use. So this is first the first supporting technology to the mobile GIS. The second one is the wireless communication. So basically, and the third one is the positioning technology. So the wireless communication actually is a very important supporting technology to the mobile GIS. So as we mentioned earlier, the mobile GIS and also the web GIS they could overlap with each other, and the overlapped region they are called the connected mobile GIS. So of course, when it's a mobile device, so usually we won't have a cable to connect to the mobile device. We most of the time we are using the wireless communication network to communicate to transmit information. So the wireless communication is also one of the supporting technology in the mobile GIS. And the third supporting technology is the positioning technology. So as we mentioned, mobile devices they have sensors to collect information, and one of the very important information, one of the most important attributes is the location information. So the positioning technology is of course one of the most important supporting technology in the mobile GIS. So let's talk about the three one by one. So in terms of the mobile device, so basically it could be the mobile phones, like the cell phones or smartphones, satellite phones, or it can be separated as the low end or like the high end, like the smartphones that we are using quite commonly in the modern age. And beside the mobile phone, the mobile devices, they could be the portable computers as well. It could be tablets or it could be laptops as well. And there are some special devices, for example, like the GNSS or GPS navigation systems that can be counted as the mobile device as well. But of course, that's just one example. You can also have other types of special devices created to support the you can say mobile usage. Right, beside that, that we can briefly, like I said, most of the mobile devices that people are using, they are the smartphones. So let's take a little bit look at the brands that we have in terms of the smartphones in the 2020. So this was also statistics from an online source. So basically, the smartphone brands are you can say the biggest market share is from Apple iPhone. So they occupy 23% of the market, and which is is a very large market share. And the next one actually is Samsung. It covers 17% of the market share in 2020, and then Xiaomi occupies 11.6%, and Oppo 9%, Huawei 8.6%, and also others are about 30%. So these are the smartphone brands in the 2020. So as you can see, most of the largest market share in terms of the brands, they are from the Apple. But however, the other thing that you can see is in terms of the operating systems. So as you can see from the Samsung, Xiaomi, Oppo, Huawei, and many others, other brands, they are actually following the Android. Right? They are basically following the Android system from Google. So you can also view the market share of the mobile devices in terms of the operating systems point of view. So as you can see, this is another you can say statistics to calculate the market share of the mobile operating systems from 2009 to 2018, and they are different you can say lines over here, and the one of the most you can say important and significant or obvious line is this orange line, and that indicates the Android, or that indicates the Android. And in terms of so as you can see, in terms of the market share for the operating system, Android actually occupies near 80%, or near 80% of the smartphone market. And on the other hand, in terms of the you can say the iOS, the Apple's iOS is about about 20% of the market share in these statistics till the 2018. And there are other operating systems, but however, most of the you can say market share are already being occupied by the Android and also iOS. Okay, the Android and also iOS. So they are actually it's actually not a very healthy well, you can say ecosystem or competition in terms of the mobile operating systems. There are other you can say operating systems over here, BlackBerry and Samsung, Windows and others. So basically, but however, they really occupied just a few of the percentage of the market share. Well, it's about I think it's about it's less than 5% or even 3% of the market share for other operating systems. And like I said, it may not be a very healthy way to in terms of the mobile operating systems. Okay, so basically that's the current situation. So we can debate on we can discuss these market share of the mobile operating systems in the class. And on the other hand, in terms of the wireless communication, so this is one of the you can say general comparison between different technologies. For example, like the 4G, the LTE is about over here the range and also the data rate. So the range is large and also the data rate is also high as well. So this is one of the common you can say wireless communication for the smartphone nowadays. And the older generation, the 3G is over here. The data rate is very very much slower than the 4G LTE. And even older generation, the GSM is over here. Their coverage is pretty very similar, but however the data rate is their main differences. And in terms of the for example the you can say ultra wideband is over here, and also Wi-Fi is over here, and Bluetooth over here. Actually, in terms of the Bluetooth, the newer generation of the Bluetooth, the Bluetooth LE, actually it claims that it can reach to hundreds 100 meter, but however whether or not it can successfully transmit a signal is another thing, because it could be easily like influenced by the you can say the medium between the you can say between the two nodes. And in terms of the sensor networks, the older, like the traditional sensor network, usually like to use the ZigBee communication protocol, which covers a larger range to some people will say it's more than 100 meters, but however in reality it's about 10 meters coverage. And but however you can say the power consumption of the ZigBee is lower, but together the data rate is also lower as well. And NFC for the you can say for the payment is also over here. The data rate is small, and also the range is very small as well, but it's for a specific application purpose. And the other thing is that there is actually one popular or one recent development in terms of the wireless communication, which also claim to be a wide range of the communication network, and also is a low power consumption. So the name is called low power wide area network, or some people will just call it LPWAN, or low power WAN. And as you can see, I put it over here. The range is high. It claims that it can go it can reach 10 kilometer away from each other, and but however their data rate is very small. Right? The data rate is very slow, so you cannot transmit a lot of information across this LPWAN network. But however, the reason I mention it is because with the advance of the IoT, the Internet of Things, people want to use want to define and want to use a communication network that has low power consumption and wide area coverage, and because they assume that the IoT devices are there, you can say the requirement of transmitting information is not they are not transmitting a large data across from the IoT devices. So in this case, they don't need a high data rate in this case. So we have a lot of we have many LPWANs defined to support the IoT applications, and you may hear some of them. You may hear some of them, including the NB-IoT, and including the Sigfox, and also including the LoRa. Alright, so they are those communication protocols. They belongs to the LPWAN. Okay. Okay, so this is just to give you guys some you can say some reference. And in terms of the positioning technology, so basically, like I said, the mobile GIS applications, they are usually required to be to know the location of the device. And in this case, we can support you can say more customized or personalized services. And on the other hand, you can collect the geographic information by using the positioning technology to know the location of the device. So in order to retrieve the precision, there are many technologies that can allow us to achieve that. The one of the famous one is the GNSS, the Global Navigation Satellite System. That so most of the smartphone they have these type of sensors built in, so that you can communicate with the satellite. You can receive the signal from the satellite, and then to calculate the location of the device. And on the other hand, you can use the serial network supported by the smartphone, and then to find out the position of the device as well. And assisted GPS, the AGPS, and or in the indoor, actually you can use The IMU, the inertial measurement unit, this is also one popular way to measure the indoor precision to support some indoor applications. So the reason for that is for the indoor environment, you cannot receive the signal from the satellite. So in this case, we need other ways for the positioning, and IMU is one of the way to do that. And of course, there are many other ways. For example, visual based by using the camera, and one of the famous technology is called the SLAM, the simultaneous localization and mapping, or SLAM, the simultaneous localization and mapping. So, which means that you can use different, you can say, sensing technology, like using the optical sensors, like the traditional camera, or by using some radar or some other signals, some other sensor signals, and then by combining them together, then you can perform the SLAM, you can say, algorithm, and to map the corresponding environment. And in the meantime, you can position the device itself in that, you can say, in that environment. So this has been used in many applications as well. For example, like some vacuum cleaner, some automatic vacuums, like iRobot, they are using the SLAM to find out, to map the floor plan, and also to find out where the vacuum is inside this floor plan, and then so that you can arrange the cleaning schedule, and also to go back to the station by yourself. So that is SLAM, which is also one very important technology, especially for the indoor positioning. And other things are like the IP address, and also like you can kind of like guess the possible region that the device locates by using its IP address, or finding out the serial towers of that device. And RFID, Wi-Fi, Bluetooth, Zigbee, these are can be used as the network for the positioning, or RFID can also be used as the, you can say, occurrence sensors to find out a general location, a local location that this device occurs. And then LPN, the low power wide area network, can also serve as the positioning network as well. And there's another one that is quite famous and also important for the indoor positioning, which is called the ultra wideband, the UWB network. And that actually can achieve, that actually becomes a quite mature technology nowadays, and their positioning accuracy for the like X and Y, the planary X and Y positioning can reach to 10 centimeter. It can reach to 10 centimeter. So which is a pretty good accuracy. But however, the 3D positioning it needs to be it needs to have some further investigation to find out how to improve the 3D positioning by using the ultra wide band sensors or ultra wideband technology. The reason for that is because of the you can say the location of those you can say reference stations. Okay, so basically these are the three main supporting technologies that help us to achieve the mobile GIS.